So, hello everyone. Today we will discuss the methods for the contact angle measurement. So, before that we will quickly review the last lecture. So, in the last lecture we discussed different experimental method to measure the surface tension or interfacial tension. So, these methods were classified into three categories: detachment based method, shape of static drop based method and the dynamic based method. In the detachment based method we discussed about the we want to form a special drop, or you can say drop volume method. Then you want to detach a ring from the top of the surface, that is the ring method, or you want to detach a plate, that is a plate method. Then in the shape of static drop we discussed the pendant drop and sessile drop. Also we discussed the spinning or the rotating drop methods. And then dynamic methods we discussed the flow methods, we discussed the capillary wave method, also we discussed the bubble pressure method. So, these were the different methods being used to experimentally determine the surface tension or the interfacial tension. Now, today we will discuss how we can determine experimentally the contact angle. So, in this lecture we will first see the basics of contact angle. So, the contact angle is resultant of different interfacial forces, solid liquid interfacial forces, solid vapor interfacial tension, as well as the liquid vapor interfacial tension. So, we will just see at a contact point there will be three interfacial tensions, and resultant of, or the you can say equilibrium between these three interfacial forces results in the formation of a certain angle, that angle is known as the contact angle. So, first we will see how it is related with the Young's equation, then we will see different experimental methods like the goniometer to measure the contact angle. Then once you are having a drop on the surface, you have to image it, and after imaging you can do its analysis, that is known as the drop shape analysis. And also we will quickly see, if it is not a solid surface, it is a powder. If you want to estimate the wettability or contact angle on a powder, then we will go for the capillary methods or the column methods. And finally, we will just see what is difference between the static contact angle and the dynamic contact angle. Also, we will see contact angle and the spreading or wetting of a surface. So, first you are considering a solid surface, and on the solid surface you are putting a drop of the liquid. So, this is a solid, this is you can say air vapor phase, this is a vapor phase, this is solid phase, this is a vapor phase, and in between there is a vapor phase and the liquid phase. So, we are going to have three interfacial tension. One is the between the solid and vapor, that is the solid vapor surface tension, interfacial tension. Second interaction will be liquid and vapor. So, that is the liquid vapor interfacial tension, and third interaction will be between the solid and the liquid. So, that is the solid liquid interfacial tension. So, at a contact point we are seeing the three forces are acting. So, we can simply go for the force balance, and this angle is known as the, if you draw a tangent, this angle is known as the theta is known as the contact angle. So, if you go for simple force balance, so we will just see gamma solid vapor is equal to gamma solid liquid plus gamma liquid vapor cos theta. So, the gamma liquid vapor cos theta equal to gamma solid vapor minus gamma solid liquid, and this is known as the Young's equation. So, Young's equation says, if you know the interfacial tension at different interfaces, you should be able to calculate the contact angle. Either way, if the contact angle theta is known, then we should be able to calculate the interfacial tension. So, typically as you know, this gamma liquid vapor we can experimentally measure, as we discussed in the last class, using different method, detachment method, drop shape analysis method or the dynamic method. We can experimentally calculate gamma LV liquid vapor interfacial tension. Theta contact angle we will discuss today how we can experimentally measure the contact angle. These two we can measure experimentally. Now, gamma solid liquid, this we can calculate from the work of adhesion. So, work of adhesion is gamma liquid vapor plus gamma solid vapor minus work of adhesion WSL. So, from the work of adhesion we can calculate the gamma solid liquid, but how to calculate gamma solid vapor. So, calculation of the solid vapor interfacial tension. So, we will see in the next class, we cannot directly experimentally calculate the solid vapor interfacial tension, but using the Young's equation you should be able to calculate using Young's equation, using the contact angle data and using the liquid vapor interfacial tension, you should be able to calculate the solid vapor interfacial tension, that anyway we will discuss in the next class. So, what we are saying, experimentally we can measure the contact angle, experimentally we can measure the liquid vapor interfacial tension, and all three are related using the Young's equation. Now, as I was telling, the work of adhesion is equal to gamma liquid vapor plus gamma solid vapor minus solid liquid interfacial tension. So, in place of gamma solid liquid, if you put in the Young's equation, so Young's equation was gamma liquid vapor cos theta is equal to gamma solid vapor minus gamma solid liquid. So, what it says is here in place of gamma solid liquid is calculated from the work of adhesion. So, this is the Young's equation, and if you put gamma solid liquid in terms of work of adhesion, so it will be like gamma liquid vapor cos theta is equal to gamma solid vapor minus gamma liquid vapor minus gamma solid vapor minus work of adhesion W solid liquid. So, this will be simply cancelled out. So, this will be, it will come here. So, this will be a gamma liquid vapor 1 plus cos theta is equal to work of adhesion W solid liquid. So, if you know the contact angle, if you know the liquid vapor interfacial tension, both we can measure experimentally. So, you should be able to calculate the work of adhesion as well. So, work of adhesion is liquid vapor interfacial tension into 1 plus cos theta, theta is the contact angle. So, we can estimate work of adhesion, we can estimate the solid liquid interfacial tension if we can experimentally measure the contact angle as well as the liquid vapor interfacial tension. Now, before we proceed further, what should be the condition when the contact angle will be formed? So, if you remember the previous class, we discussed the spreading, and spreading occurs when there is a difference between the work of adhesion between solid liquid as well as the liquid liquid. So, you can say when there is a difference between the work of adhesion and work of cohesion. So, this difference is known as the spreading coefficient. So, if you simply put the work of adhesion, solid liquid means adhesion, liquid liquid means cohesion. So, work of adhesion, if you simply put from the last slide, so and work of cohesion will be twice of the gamma liquid vapor. So, we will end up with gamma solid vapor minus gamma liquid vapor minus gamma solid liquid. So, solid vapor interfacial tension minus liquid vapor interfacial tension minus solid liquid interfacial tension, and depending on the value of S, we see if there will be a spreading or there will be no spreading. So, we can other way see if the difference between the solid vapor interfacial tension minus the sum of liquid vapor plus solid liquid interfacial tension decides whether there will be the spreading or no spreading. So, there will be two conditions. In one case S can be greater than 0, in other case S will be less than 0. Greater than 0 means this value is higher, less than 0 means this value is higher. So, if gamma solid vapor is greater than the second term, then spreading coefficient will be positive. In this case, we observed the spreading, it means liquid spontaneously spreads on the surface, and we call this phenomena as a total wetting. It means it is totally wetted by a liquid, a solid surface is totally wetted by a liquid. In this case, we will not observe the contact angle phenomena, or you can say the contact angle is 0, means it is a total wetting. Now, next case, if the surface tension of liquid vapor plus solid liquid interface is higher than that of the solid vapor surface tension at solid vapor interface. In this case, the value of S will be less than 0, then there will be no complete spreading, but the liquid drop will form a spherical cap. It will form a spherical cap at the equilibrium, and this process is known as the partial wetting. And in this case, we can experimentally observe the formation of the liquid drop or spherical cap, and if you draw a tangent line, this angle is known as the contact angle. So, for the formation of the contact angle at a surface, the value of spreading coefficient should be less than 0. Then there will be a formation of a certain angle, and that of course, we can measure and see what is the contact angle of a particular surface. Now, if you just see, the spreading is a function of all three interfacial tensions: solid vapor, liquid vapor and the solid liquid. And in the Young's equation also, the cos theta is related to the all three interfacial tension. So, depending on the value of these interfacial tensions, the shape of that spherical drop varies, and as the shape of spherical drop varies, we will observe the different contact angle. So, here I have listed one example here. So, it says that all three interfacial tension is known. Solid vapor is the gamma solid vapor or gamma 1 is equal to 27 millijoule per meter square. Gamma liquid vapor is equal to 40 millijoule per meter square, and gamma solid liquid is 11 millijoule per meter square. And also it says, if you put the drop of that liquid on the surface, the contact angle is observed to be 64 degree. So, if you want to verify this, So, the first thing we will just see whether there will be the spreading or not. So, if you want to calculate the spreading, you have to calculate the value of S, and the value of S is gamma SV minus gamma SL minus gamma LV. Okay. So, this will be like gamma solid vapor is 27 minus solid liquid is 11 minus 40. So, this will be coming out to minus 25. So, as it is less than 0, it means there will be partial spreading and the formation of contact angle will take place. So, the first thing we will observe some contact angle. Now, what should be the contact angle? So, in that case you have to verify with the Young's equation, which says cos theta is equal to, if you just see the Young's equation. So, it says cos theta is equal to gamma SP minus gamma SL divided by gamma LV. So, all three is known. So, gamma SV minus gamma SL divided by gamma LV. So, it is like SB gamma SP 27 minus 11 divided by 40. So, this is like 16 40. So, it will be close to 0.4, it will be close to 0.4. So, theta value will get about close to 65 degree, and experimentally we are also getting 64. It means it agrees with the claim. So, what we have observed is, the first thing you have to see what is the value of spreading coefficient, and if the value of spreading coefficient is negative, there will be a formation of certain angle. So, that first agree there will be some angle, we will observe it, and then the data should agree with the Young's equation. So, it from the Young's equation we calculated the what should be the theoretical contact angle, and that is matching with the experimentally observed one. So, we can say this data is validated. Now, the first method we use to measure the contact angle is the goniometer. Zisman and co-workers employed a microscope objective to view the angle. So, if you are having a microscopic objective, so whatever light microscope was there, the same microscope was used to see the angle. Typically, the microscope is vertical. If you make it horizontal, you should be able to see, or you should be able to record what is the shape. So, here this is a camera which is going to record what is happening here. This is a light source, this is a filter, and here this is your surface or this is your sample, and you are going to put a drop over here, and the shape of drop will be recorded by the camera. You can say this is like a horizontal microscope, and this whole setup is known as the goniometer. So, if you say the instrument being used to determine the contact angle is the goniometer, or we say contact angle goniometer. So, this is a surface. If you put the drop like this, so the camera recorded the shape, and once this shape is known, you should be able to determine the angle from both the side, left side as well as the right side, and this angle is the contact angle. So, as we discussed, if you put a drop, or you can say the formation of drop is related with the surface tension, but if there is a bigger size of drop, there will be the interference of gravitational forces as well. So, we typically go with the small side drop, forms the shape which depends on the interfacial tensions. So, if you have the small drop, we are neglecting the effect of gravitational forces. and once this camera have recorded the image or the shape of the drop, which we can analyze this shape to analyze or to determine the contact angle. So, this is, you can say this setup is like a horizontal microscope which is having a light source, a filter and a camera. This is the stage where you are going to put your sample, and using a syringe you are going to add a drop of the liquid. If you put that drop of the liquid, depending on the surface energy of the solid and the surface energy of the liquid as well as the interfacial energy of the solid liquid, there will be a formation of the drop, and the formation of drop will have certain tangent or certain angle at the surface. That angle is known as the contact angle. Typically, the volume of drop we keep in the range of 1 to 10 microliter. So, we try to keep as small as possible, because to avoid the interference of gravitational forces. So, there are three things we have to consider when we perform the contact angle measurement. First is the small volume. So, typically we go for the 1 to 10 microliter. To say the shape of drop is totally dependent on the interfacial tensions, means the surface tension of solid, surface tension of liquid as well as the interfacial tension of the surface solid and the liquid. Now, second criteria is there should be also the effect of environmental factors, or you can say the external factors like temperature. So, if you put any drop on the surface, so what will happen? The liquid will try to evaporate, with time and temperature. So, both are the factor, time as well as the temperature. So, liquid try to evaporate with time as well as the with temperature. So, what you have to do is you have to maintain the temperature in such a way that there should be minimum or the no evaporation of the liquid, and try to keep the volume of the drop as small as possible. Now, the third thing is there, if you put a drop over here, third thing the equilibrium. If you put a drop over here, so it will take some time to reach in the equilibrium. If you want to measure the static or equilibrium contact angle, so we have to measure the contact angle when it becomes, the value of the theta becomes constant, because typically what will happen, if there is a interaction is taking place between the solid and the liquid. So, accordingly the drop shape will keep changing. So, within few seconds there will be change in the drop shape, that is coming because of the interaction between the solid and the liquid, and once it reaches to the equilibrium, the theta value becomes the constant. So, within a few seconds, less than maybe you can say 60 seconds or so, the contact angle value reaches to the equilibrium. So, there are two things, the decrease in the contact angle initially because of the equilibrium, and if you go for the higher time, the decrease will be in the contact angle because of the external factors like time and temperature. So, while we are performing the contact angle measurement, we should be careful of these three factors, the volume, the external factors as well as the equilibrium condition. Now, once your drop shape has been recorded by the camera, you should be able to analyze the angle between the surface and the liquid. or you have to draw a tangent. So, this method is known as the tangent method. So, this is the liquid. So, what we have to doing, we are drawing a imaginary circle, and after drawing the imaginary circle you draw a tangent like this, and this angle is the contact angle. So, if you can analyze the angle theta here, that to analyze this you have to consider this as a small circle and this is a part of the circle, then we can easily analyze the value of the theta. So, one method is, the simplest method is like this, you are having a circle, perfect. This is, let us say, your contact angle. Once you can fit a circle, you know what is the center point, and from the center point you can find the value of r, what is the radius of that circle, and of course, this is your contact angle theta. So, now if you know the value of r, also this value of h you can measure from the experiment, or you can analyze from the image. So, you can analyze the h, you know them now after fitting a circle you know what is the length of r. So, you should be able to calculate the value of, if you draw a tangent line you should be able to calculate the value of contact angle. So, one simplest theorem says, let us say this is a triangle and this is the tangent. The angle at of the tangent is equal to the interior opposite angle. So, this theta will be same as this theta. So, the angle of tangent will be equal to the opposite interior angle. So, if you can determine this angle theta, that will be same as this contact angle theta. Now, if you want to determine this r is known, this is also r. So, this is the r minus h. So, if r is known, r minus h is known, also experimentally we know what is the length, what is the value of this length. So, after knowing all these three, and typically this angle will be 90 degree. So, in this way you should be able to analyze either the cos theta or sin theta or the tan theta, and we can calculate the value of theta, and the theta is the contact angle. So, what we are saying is, we are drawing a tangent, before drawing the tangent we are assuming this part, the shape is the part of the imaginary circle, and from the imaginary circle if it is a center point, now we know what is the value of its radius, and we can calculate the value of the theta. Now, as I told, this contact angle is the resultant of three interfacial tension, that is the solid liquid, that is the happening at the interface, solid liquid, this is the solid vapor, and this is the liquid vapor. So, depending on the value of these three interfacial tensions, there will be formation of different drop shapes, and the different drop shapes means different contact angle. So, this is just one example that although there is a formation of the shape, but the shape varies depending on the value, individual value of surface tension or interfacial tension. So, here we can say it is less than 90 degree contact angle, this contact angle is the, means it is like a half circle, this is like a half circle. Contact angle 90 degree, and if it is more than half circle, the contact angle is more than 90. So, this surface we call the hydrophilic and this one contact angle more than 90 we call the hydrophobic. So, we see now although there will be formation of a drop shape, but this shape will depend on the value of, or you can say individual value of the interfacial tensions. So, if you can analyze the contact angle, this is very simple method. If you put a drop of the liquid, wait for the equilibrium, capture the image and analyze the contact angle. And once the contact angle is known, now we can think over, or you can recalculate what are the values of the solid liquid or the solid vapor interfacial tensions. So, this was the tangent method. So, here I have listed one more example. So, as I was telling, if you can fit the imaginary circle like this, experimentally by analyzing the image, you know this is the height h, this length is L, this is the A is the radius. So, this will be the A minus h. Now, the angle of tangent should be equal to the interior opposite angle. So, this angle is the theta. So, here we know this is the A minus h, this is the A, then we should be able to quickly estimate either sin theta or the cos theta, or you can say the tan theta, and here cos theta will be, this is the theta is equal to A minus h upon A, or you can say 1 minus h upon A. So, if you just rearrange it, so this will be like h upon A is equal to 1 plus cos theta, then h is equal to A 1 plus cos theta. So, this is just one method. So, that is what we are discussing. If you can fit a imaginary circle, and then you should be able to estimate the value of the contact angle depending on the what is the radius of the fitted imaginary circle. Now, this is the one case. Next, another case may be your surface is heterogeneous. So, heterogeneous means, let us say you are having homogeneous circles. So, you are having a drop, it is having a homogeneous surface, having homogeneous chemical and the physical properties. So, this theta left and theta right both should be same, theta left should be value of theta right. But if it is a heterogeneous surface, if you are having a heterogeneous, you are having a heterogeneous surface, in that case the contact angle of the both left and right side may not be same, it may come like this. So, here you are having a different contact angle, and here you are having a, it means it says that theta left is not equal to the theta right. Just to analyze this, we have to fit now the whole shape cannot be the part of one imaginary circle. So, you have to fit the different circles. One circle will be like this. So, you have to fit, you can fit the one circle to the left side, at the same time you can fit the second circle to the right side. So, it is not necessary that whole shape need to be fitted with the one circle, because if both sides because of some physical or the chemical heterogeneity at the both surface, the surface tension and interfacial tension are not the same. We are going to have the difference between the left and right contact angle. In that case, you might need to fit different circle for the left and different circle for the right. Now, the second method is, as I was telling, if you are having attached with camera with the computer and some image analysis software is there, it can easily calculate what is the value of H and what is this length. Let us say this is the R, this is R. So, this will be the whole length will be the twice of the R, and here we are saying this angle is the theta. So, if you just simply write tan theta, so tan theta will be the H upon R. So, this method is known as the height width method or the theta by 2 method. So, if you calculate the theta is equal to tan H upon R and the contact angle, a whole this angle is, you can write this theta 1. So, the theta, if you just see the simply theta is equal to twice of the theta 1 R. So, here the contact angle will be twice of the small theta. So, this is another simplest method, but we should be careful when we are recording the image or the shape. It should be recorded at the equilibrium if you want to measure the static contact angle, otherwise it varies like this. With time this, with time like this, and then it reaches to the equilibrium. So, this time frame is few maybe you can say 0 to 60 seconds it takes typically. So, you have to see at what time there is a no change in the shape, and that time you have to record the shape and analyze, because whatever shape you take you should be able to calculate the contact angle, but if the time you recorded the shape was not at the equilibrium, you may end up getting the wrong contact angle. So, this is another the easy method. So, this is height width method or the theta by 2 method. So, theta 1 is equal to H by R and theta is equal to twice, let us say you can write theta 1, then theta is equal to twice of the theta 1, that is it. So, we discussed two methods, either you have to draw the tangent or the theta by 2 method. Now, if you remember the last class when we are discussing the measurement of the solid liquid or liquid vapor interfacial tension. So, in the detachment method, one method was the Wilhelmy plate method. So, in the Wilhelmy plate method, the plate is there in the contact with the top layer of the liquid. If you pulling it out, then the force applied should be equal to the surface tension of that liquid. Now, if you just see, this is again the plate is a solid surface and it is coming into contact of the liquid. So, the contact line also forms certain angle like this. The contact line is forming certain angle both side, and that angle is also contact angle. So, in this case when we are measuring the liquid vapor interfacial tension using a plate method, you should be able to also calculate the contact angle. So, if you remember, total weight will be weight of the plate plus resistance coming from the surface tension. So, that is the gamma cos theta into P is the perimeter of the plate. So, now we can just rearrange. So, it will be like a gamma cos theta is equal to delta W upon the P. So, using this Plath method, again we should be able to calculate the contact angle, because this gamma liquid is already estimated from the delta W and P is the perimeter. Perimeter is fixed because you know what is the size of the plate, and delta W the instrument will experimentally measure. So, we can calculate the contact angle as well as the solid as well as the liquid vapor. Here gamma refers the gamma liquid vapor interfacial tension. So, further let us say this is the meniscus of the plate, this height is touching up to the edge, this angle is the theta. So, we can digitally analyze this height, and if we know the height we can simply calculate the sin theta as 1 minus rho g h square upon twice of the liquid vapor interfacial tension, or we can say this, you can write this term in terms of capillary length. So, capillary length, so it says 1 minus 1 by 2 h upon a chi square. So, capillary length is defined a square is equal to rho upon gamma upon rho g. So, this is the capillary height. So, if you put here gamma upon rho g as a square, so it will be simply h upon a ka whole square. So, what it says again, if you are having a computer control device, you can digitally analyze the image, and if you can measure the what is the height of this meniscus, you should be able to easily calculate the value of the contact angle using the Plath method as well. We need not necessarily put the drop of liquid on the surface, but here the limitation is we cannot play much with the material of the plate. There is a limitation material of the plate. So, in this method we have limitation because we cannot play much with that particular surface, because there are two constants. One, it should be the bioinert with the liquid. If you remember, when we measure the liquid vapor interfacial tension, so there are two conditions. The material should be inert, it should not chemically interact with the liquid. At the same time, it should be of the light weight. So, although the theoretically we can calculate, but because of this complexity we mostly go for the goniometer if you want to analyze the contact angle, and we go for tensiometer if we analyze the surface tension. If you are having a flat surface, now if you are having a powder sample, then can we measure the contact angle of a powder sample? So, for this we go for the column methods or the plug method. So, we prepare a porous plug in which the powder is compressed. So, it becomes like a capillary tube which is filled with the your fine powder. Now, if you are having a capillary tube, you are passing a liquid, we are going to observe the delta P pressure drop, and that pressure drop is related with the interfacial tension using the Young's Laplace equation. If you remember, we discussed about the Young's Laplace equation. So, it says the pressure difference is directly related to the interfacial tension and inversely related to the r distance, or you can say the radius, capillary radius. And this is interesting, the porous plug is considered as a bundle of capillaries with the average radius of the r. So, we are considering the n number of capillaries in which we are passing the non-wetting liquid. Non-wetting liquid is passing through n number of capillaries of radius r, and using the Young's Laplace equation you should find the value of delta p. We can measure experimentally cos theta, we are going to determine gamma LV liquid vapor interfacial tension is known, the which non-wetting or wetting liquid we are passing through. R we are considering the how the non-wetting liquid is passing, we are considering there are n number of capillaries, or you can say bundle of capillaries with the radius r. So, depending on the value of theta, delta p varies, or you can say if you can measure the delta p, you should be able to calculate the value of the theta. Now, here one more parameter is there, r. How to determine the value of average capillary radius? So, for this what we will do, we will pass the wetting liquid through the same column. So, if you are passing the wetting liquid through the same column, means cos theta is equal to wetting means 0, cos 0 is theta, cos theta is equal to 1 because theta is equal to 0 degree. So, we are getting cos theta is equal to 1. So, in this case if you are passing a wetting liquid, delta p naught, we are writing delta p naught is equal to the twice of the liquid vapor interfacial tension of the wetting liquid divided by r, and this was the equation for the non-wetting. If you can eliminate r from these two, because we are having the same column, the r can be eliminated using this equation. So, we will end up with cos theta is equal to delta p into surface tension of the wetting liquid divided by delta p naught into the surface tension of non-wetting liquid. So, in this method, if you know, if you can experimentally measure the delta p, then using the Young's Laplace equation you should be able to calculate the contact angle. So, here we say delta p is playing with the contact angle, and this method we use for the powder samples, because at the powder sample we cannot put the drop of the liquid and we can analyze it. So, for powder sample we are making a porous plug, we are compressed and we are measuring the delta p, and delta p is directly related to the interfacial tension and inversely related to the capillary radius. Now, we talked about the static contact angle. As we told, if you put the drop of liquid, there is going to be the change in its shape, and when there is a change in shape, means it is reaching to the equilibrium, then it will reach to the equilibrium, we capture it, we measure the static contact angle, that is known as the equilibrium contact angle. But at the same time, so this is, you can say, the static contact angle, but at the same time we can also measure the dynamic contact angle. We can see there are two things we can see. First thing, we can see how theta is changing with time. theta will keep on decreasing if you capture the image at different time interval. So, theta is changing. So, it will be like this, theta will change up to here, we can say this is coming because of the equilibrium. If you go for further higher time, there will be further decrease in the contact angle, and this decrease is coming because of the external factors. Like a temperature, like evaporation, if there will be vapor pressure, temperature, there will be some sort of evaporation, and with time there will be loss in the volume of liquid. External factor means what it is doing? It is doing the loss of the volume of the liquid. So, up to here we call the static or equilibrium contact angle, but in case of dynamic contact angle, what we are doing is, first we can also, one example of dynamic contact angle is the advancing and the receding contact angle. So, if you remember the last lecture, in this case we are putting the drop, it is having a contact angle, that is theta a, we call advancing contact angle, but if you are pulling it out, we are getting the lesser contact angle. A typically value of advancing contact angle is always greater than the receding contact angle. This is the advancing and this is the receding, and this phenomena is known as the contact angle hysteresis. So, this dynamic contact angle or the contact angle hysteresis is helpful, or it is saying that it is meta stable state, it is not in the equilibrium, that is why there is, it is changing, the contact angle is changing, and at the same time it also gives the information about some physical or the chemical heterogeneity of the surface. So, physical heterogeneity, it may be some rough surface, it may be some air is trapped on the surface. Chemical heterogeneity means the chemical composition is not uniform. So, at one place the chemical composition is different, at the second case the chemical composition is different. So, in that case, as we discussed, in case of chemical heterogeneity we can use the Cauchy equation to measure the contact angle, and in case of physical heterogeneity we use the Benzal equation to measure the contact angle. So, I will conclude here this lecture. So, today we discussed what is the contact angle. If you are putting a drop of the liquid, it forms a particular shape, and the shape depends on the interfacial tensions. It depends on the all three interfacial tension at the contact point. Now, when there will be the formation of contact angle, formation of contact angle will take place when the value of spreading coefficient is less than 0. So, we can first calculate the value of spreading coefficient. If it is less than 0, it means there is a formation of a drop, and the shape of drop will depends on the value of the individual surface tensions or individual interfacial tensions. If you are dealing with the solid liquid vapor, so this will be the solid vapor interfacial tension, liquid vapor interfacial tension, and the solid liquid interfacial tension. Then we discuss experimentally, we determine using the contact angle goniometer. So, contact angle goniometer is like a horizontal microscope, which is having a light source, it is having a filter, and other side it is having a camera, and in between it is having a stage. So, on the stage you put your sample, put a drop of the small drop of the liquid, capture the image and analyze the image to determine the contact angle. And to analyze the image, we can analyze using the tangent method or the theta by 2 methods. So, in both the cases what we are assuming is whatever shape you are observing in the camera is a part of imaginary circle, and if you can draw the imaginary circle means I know what is the radius of that imaginary circle, and once the radius is known, I can easily calculate the what is the angle of the tangent. Also, if you analyze the image, you know what is the height of that shape, then again you can calculate easily the what is the height and width of that particular drop on the surface, you should be able to analyze the contact angle. Now, apart from this goniometer, we can also use the plate method, the method which is also used to measure the surface tension of the liquid. So, here in case of plate, the liquid forms a certain angle and we can calculate depending on the change of the weight of that, what is the weight is required to pull out the liquid from the top layer or the interface is equal to the surface tension. At the same time there is a contact line. So, whatever perimeter we are considering, that perimeter is equal to P cos theta and the cos theta is the contact angle. But in this case the limitation is the material of construction, because if you want to measure the surface tension, the material should be inert and it should be of lightweight. So, typically we go with the platinum plates, but if you want to measure the solid, it means you are going to change the plate with the material of the interest. So, that may not be feasible. So, most of the time we use the contact angle goniometer to measure the contact angle. Then we discussed if it is not a flat surface, it is a powder sample, how to measure the contact angle of a powder sample. So, for this we have to prepare a porous plug in which you have to compress your powder material, then you have to pass through the wetting liquid as well as the non-wetting liquid and you have to measure the delta P, and delta P is directly proportional to the interfacial tension and inversely proportional to the size of capillary using the Young's Laplace equation. So, in this way if you measure the delta P for both wetting as well as non-wetting liquid. So, for non-wetting liquid we are assuming it is forming some contact angle, and for the wetting we are considering the contact angle is 0, it means it is completely wetting. So, in this way we can calculate the contact angle of a powder sample. Then finally, we discuss the what is the meaning or significance of the static as well as the dynamic contact angle. So, thank you.